We're going to start with the example 4.1 to explain the concept of effective interest rate and nominal. So I'm going to start with a very simple example. This one, you're depositing $2,500 in your account at time 0. And you want to know how much money you're going to have at the end of year 8 if in this example we're going to assume the interest rate is 8% per year compounded semi-annually. It means your money is going to receive the interest at the end of each 6 months. So the best way to do this example is this. Use a unit of time as 6 months. So if the nominal for 1 year is 8%, for 6 months it's going to be 8 divided by 2, which is 4%. So if I have year 1, year 2, in this one we're going to have 1 period here, 2, 3, 4, and we're going to go this one. Actually, I'm going to put this on the top. You're going to have 16 period. So that way my interest rate for a unit of time is going to be 4%. So the rest of them is the same as before, like we did in chapter 3 here. F is going to be equal to 2,500. F given P. And the interest rate for 6 months is 4%. And the number period is 16. Why 16? Because you have 8 years. Each year consists of 6 months. So you have 16 period. So once you do this, you go to table, and this factor is 1.8730. Simplify this equation, and the future value of your payment is going to be $4,682.50. So as you can see here, anytime the money is compounded more often than once a year, what the best way to do is just try to change your unit of time here from 1 year to 6 months. The nominal for 1 year is 8%. For 6 months is half of that, 4%. Now you're going to increase the number of periods from 8 to 16. So the same as before. All the equations are going to be the same, and the only difference you're using 4% for 6 months rather than 8% for a year. In this example, this is actually one method. There's a second method you can use here, which I'm going to explain here. Rather than using 6 months as unit of time here, use 1 year as unit of time. There's nothing wrong with this. But you will see that it's going to be much harder than using 6 months. So I'm going to use 1 year as a unit of time here this time. The nominal for 1 year R is 8%. Now, in order to find the F, same as before, is going to be equal to 2,500 P given F. For the I, what we should put here? You cannot use 8% because 8% is the nominal for 1 year. You have to find effective. So I'm going to write the effective from this equation. It's going to be 1 plus R over T to power of T minus 1. The nominal for 1 year is 8%. You have 2 sub-periods within 1 year. That's T value is equal to 2 power of 2 minus 1. That's going to be the effective for 1 year. It's going to be 8.16%. So that's what you're going to substitute here. Because the nominal for 1 year is 8%, the effective is slightly larger than the nominal. So that's the one you can. But the number of periods is going to be 8 because you're using 1 year as unit of time here. So this is going to be 8. So what's the problem? The problem here is this. When you go at the end of your book, the table that you have is either for 8% and 9%. You don't have a table for 8.16%. So that's why you cannot get this number. Unless find the P given F for 8% and 8 years, Find P given F for 8%, 9% and 8 years, and then interpolate between those two values to get for 8.16%. That's going to take time. So that's why the first method is much faster, because you don't have to do any interpolation. You just use for 4%. Here you have to do interpolation for 8% and 9%, find the factor. So I have this number, and this one is 1.8. So again, after interpolation, it's going to be 1.8730. And if you substitute, that value is going to be $4,682.45. As you can see, the answer is slightly different than previous one, because this one I'm using interpolation. That's going to have some error compared to this first method. The difference is not significant, like 5 cents.